there, this is Dr. John, your physics and math professor, and today we're going to look at why we measure angles the way we do. I'm going to give you 3 possible ways to measure angles and give you some of the advantages and disadvantages of each. We'll start off by going way back to the Babylonians. Now, the Babylonians had a mighty empire 4,000 or 5,000 years ago. They're known for things like the Tower of Babel that I drew here for you, and the Hanging Gardens of Babylon, which were considered one of the wonders of the ancient world. They also did a lot of study of the heavens and the stars in the sky, and they tried to figure out what those things might mean to us. They made some observations, like, for example, that we go through an entire phase of the Earth with the sun every 360 days, a little bit more than that. And also, there are 12 moons during that time, 12 complete phases of the moon, each lasting about 30 days. So what they did is they divided all of the heavens into 360 units, into 12 chunks of that, each about 30 degrees wide. So what they even assigned a special symbol to each of those 12 units. We call those the Zodiac today. Some people still follow that or are interested in that as well. So this is where we get our 360 degrees in a circle. Children today will learn circles, will learn angles using this Babylonian system of measuring angles. It's the most common one. Even scientists, when they're doing science, they'll use a different system, but they'll use this system in their normal everyday life. Now we're going to go to a couple of thousand years later, where we have another mighty empire that rose up called the Greek Empire. Now, the Greeks were known for a number of things like building the Parthenon. They're known for the Olympics. They also have developed the alphabet, which we use a lot of the alphabet, the Greek alphabet, alpha, beta, gamma, delta. Pi also is a Greek letter. We'll use that in our scientific work, in our math work, a lot of that to honor the Greeks and all that they did. They did a lot of work with trigonometry too, and they worked a lot with circles and angles and triangles. They also studied the stars and the skies, and they believed that circles and triangles reflected the reality of the stars, which they believed influenced our lives as well. And so here I've drawn up a circle, and what the Greeks observed is they observed that if you took a circle with a radius, I'll just give it a radius here, a radius r, and they measured all the way around from here, all the way around the circle, back to here. That distance was related to the radius in this way. The circumference all the way around was 2 pi times r. Of course, not everybody knew what the value of pi was. There's a Greek fellow called Archimedes who was one of the first to actually calculate the value of pi. He did that by putting triangles inside of circles because the Greeks liked right-angled triangles and they liked circles. So all the way around a circle is 2 pi r. Now, imagine if this radius here becomes 1. If you shrink the circle so that the radius is exactly equal to 1, what will all the way around be? It will now be just simply 2 pi because the r will be equal to 1. So we developed an angle system sort of based upon that. I'm going to switch colors here to show you that. So let's say we have some sort of angle and we're calculating all the way around the circle is 2 pi times r. And we think, well, since the circumference changes as r changes, what if we give the value of the angles around here, this angle around here? What if we give that angle the value of the circumference divided by the radius? In that case, if the radius is 1, then all the way around the circle, like this, will in fact be 2 pi, because it's going to be 2 pi times 1 divided by the radius, which is 1. We're left with 2 pi. So we actually define those angles all the way around being 2 pi, which means halfway around, just like that, is pi, because it's half of this 2 pi. And 1/4 of the way is this over here, pi divided by 2. Now, interestingly, the length of this part of the circle right here, this quarter of a circle, is also equal to pi over 2, because it's equal to this angle in what we call radians, because it's related to the radius. This angle in radians times the radius is equal to the length of this arc. We're just sort of working backwards from how we calculate the circumference. So this method of calculating angles we call radians, based upon a lot of the Greek research into trigonometry. And scientists use this a lot, or if you go into grade 11 and 12 mathematics, you're going to be using this method a lot more. We still find this to be very natural because it's easier to calculate. It's based on some bigger numbers. You're not dealing with these tiny little numbers and fractions. This is also sort of maybe based on how long a year is. So that's something maybe a little easier for us to remember. Now, maybe we should just be glad that the Babylonians weren't born on Mars, or we would have 687 degrees in a circle. Now you might wonder, is there a way of moving back and forth between radians and degrees? It's actually quite simple. I'm going to show you. I have to erase some of this, and I'll show you how that's done. Well, let's say here we had 90 degrees and we want to turn it into radians. Well, we can use a very simple ratio. For example, here we want to know how many radians this is, and we know that there's 2 pi radians in a full circle. So this is going to have to equal 90 degrees over 360. Because 90 degrees over 360, this ratio should be the same as the number of radians over 2 pi. Since 2 pi is a full circle, 360 is a full circle. So now we just solve for x. This here is 1 over 4, because there's 4 of these and 1 of these. We multiply this by 2 pi. Now we're going to be left with 2 pi over 4, or pi divided by 2. So 90 degrees converts to radians, and we get pi over 2. You might have already known that. This is just a simple way. You can use the same method to convert back and forth between the Greek method and the Babylonian method. Now, I mentioned earlier that I'm going to give you 3 different methods of measuring angles. And here we just have 2. So what would be a third one? Well, some people have suggested that maybe we can create a metric system of measuring triangles, because this is too complicated, 2 pi. This is 360. It's an unusual number. So what if we make all the way around a circle that angle to be 100 degrees in some newfangled metric system? I'm going to draw that up for you and show you what I mean. So here we have a new circle. If we wanted to make all the way around the circle to be 100 metric degrees, I wouldn't use the same symbol as I use over here. We'll use some other symbol, maybe a little M or something. Then halfway around, this would be 50 metric degrees. This would be 25 metric degrees. And we could also, if we wanted to, divide this into 5 pieces here, like that. This is 5, this is 10, this is 15, this is 20. So that works pretty well like that. It's fairly useful if you're going to divide the circle into chunks of 10. So you'll have 10 pieces of 10. Or if you want to divide it into 5, you can do that. You'll get 20 pieces of 5. But beyond that, it actually gets really hard to subdivide this circle. I'm going to show you what I mean by that and why that works. So here I've taken 360, which is the Babylonian, the number of degrees in the Babylonian circle, and our newfangled 100 metric degrees in a circle, divided into a product of prime numbers, 2, 2, 2, 3, 3, and 5, and 2, 2, and 5, 5. Because what we want to do is we want to say, how many ways can we cut apart 360 so that we don't have to deal with fractions or decimals? Because if we're going to teach this to children, we want to be able to have them divide a circle into as many different chunks as possible, into as many different sizes of pizza slices as possible, without going into fractions. So how many ways can we do this? And how many ways can we do that with 100 degrees? I'm going to list those out for you. You just take a second and guess to see how many ways we can do that. It will be how many different ways we can combine prime factors with each of these. So just give me 2 seconds. I'm going to write that out there. So here I have the result for you. I have taken 360 and divided into every way that you can subdivide this without creating fractions. And I have 21 different ways. And I've taken 100 and I have 7 different ways, which means that you can divide this into 3 times as many segments as this, which makes 360 far more practical for daily usage and better for teaching our children, even for practical applications to science or to engineering or to construction and stuff like that. So that's why we never use a metric system. We haven't created one. It's just not practical. Most young people and the lower grades learn the Babylonian system, and even adults, we like to use that. And here's what we use in our scientific research. So in the battle, the angle battle, or the angle war, the Babylonians and the Greeks won out over the metric system. And yes, the Babylonians and the Greeks did fight some wars, but never over angles. So I hope that helped. I hope you learned something. If you did, like and subscribe. I'll see you in the next video. Bye-bye.